The topic of discussion for this video is nesting. We've already seen nesting in the past. We've seen it in the form of if statements inside of if statements. So you might see something like this. You see I have a variable called num which has the value 7 right now. I might say something like if num is greater than 4. If that's true, test the next if statement which says if num is, let's say, less than 10. Just making this up. And then inside of there I might have something like system.out.println num is between 4 and 10. So because the second if statement isn't tested unless the first if statement is true. So we have an if statement inside of an if statement. Now nesting in loops syntactically is very similar. So we just create a loop inside of a loop. But logically it produces very, very different results. So if we write something like this, let's say we have for int I is equal to 0 such that I is less than 4 and I plus plus, and then inside of that I write something like for int j is equal to 0 such that j is less than, let's say, 3, j plus plus. Now let's do a couple output statements. Let's say here I say system.out.println I don't know, hi. Now inside of here I write system.out.println and I write bye. The question is, how many times will I see each output statement? How many times will I see the output statement hi? How many times will I see the output statement bye? Well, for the one that's hi, it's clearly inside of the outer for loop. So how many times does the outer for loop operate? 0, 1, 2, 3. So it's going to iterate 4 times. So we should see the hi statement 4 times. But the real interesting one is the bye statement inside of the inner for loop, the j loop. Now look at this. Now think about how this logically will work. We come down in here and it says set I to 0. Is I less than 4? Yep. Go on inside, output the value hi. No problem. And then it gets down to this line of code and it sees this loop. Set j to 0. Is j less than 3? Yep. Comes in, displays bye, then comes back up and increases j by 1. J is now at a value of 1. Is 1 less than 3? Yep. Goes back in the loop again. In reality, what's going to happen here is for every one iteration of the outer loop, the inner loop will completely execute. So all of the iterations. So that means for every one of the outer loops, this inner loop is going to loop 3 times, 0, 1, 2. So we're going to see hi, bye, bye, bye. Hi, bye, bye, bye. Hi, bye, bye, bye. And then the last one, hi, bye, bye, bye. So that means we should get 4 highs and 3 iterations for every one iteration of the outer loop. So 3 times 4 gives us 12 byes. So let's take a look. Let's run our program. Yes. We just expand this a little bit. So we have 1, 2, 3, 4 highs. And we get 3, 6, 9, and 12 byes. So we're producing some pretty significant results here. We can see that this whole inner loop is going to iterate for the whole time. So just to illustrate this a little bit more clearly and give you something a bit more applicable, think of like a spreadsheet. And you might have a spreadsheet that looks something like this. So we have 5 rows here named row 0, 1, 2, 3, 4 and 4 columns 0, 1, 2, 3. And I've just, usually when we discuss a table like this in programming, we reference the row first. So row, column, row 0, column 0, row 1, column 0, row 2, column 0, and so on and so forth. Where would you see grids like this in programming? Well, obviously in spreadsheets, but you might see it in video games. Any grid-based video game, things like chess and stuff like that. All those types of tactics games where you move across and aside, like even games like Civilization, they work in grid-based systems. So this is a very applicable thing. You can go through all the elements of this grid very easily using a nested for loop. So going back, what I'm going to do is I'm going to display all of these values in a very simple way, in a very easy way, using a nested for loop. If we did this manually, we could do it, but we'd be looking at 5 times 4. We'd be looking at 20 separate output statements. I'm much too lazy for that. That's not going to happen. So what we're going to do is we're going to go back to Eclipse, and we're going to solve the same problem. So I'm just going to get rid of this statement here. I'm going to get rid of this statement. Now I can keep I and j as my counter variables, and that would work just fine. But just to illustrate this point and make things a little bit more readable, I'm going to give them new names. I'm going to give I the name row. And it's going to go, according to our statement, we have 0 through 4, so we have 5 rows. So start at 0 and keep looping as long as row is less than 5, so we get 0 through 4. And down for j, I'm going to change this to col, short for column. And go back, we have 0 through 3, which is less than 4, so we're going to change this to less than 4. As long as column is less than 4, keep iterating. Now this is where the magic happens. I'm going to produce all of these results in one statement. So I'm going to do system.out.println, and what we need to do here is try and format it, so I'm going to get all those brackets in as well. I'm not going to print it in a grid shape, I'm just printing them all out, but we're going to get them all is what we're going to do here. So I need my opening bracket, I'm going to concatenate onto that the current row. Concatenate onto that a comma, and then I'm going to concatenate onto that the current column, and then we'll finish that off with the closing bracket. Now close this off. Oops, I missed a plus sign in there. Now think about this logically. What this means is for every row, go through every column. So looking at this, that means stay on row 0, go to column 0, column 1, column 2, column 3. Go to row 1, column 0, column 1, column 2, column 3. Go to row 2. That's how this is actually going to operate. Look at every row, and for each row, look at every column. So let's run our program. We should get everything down here. It's printed vertically, mind you, but we should get them all. Yes. And we just expand this a little bit. We can see that we get all 4 columns for row 0, all 4 columns for row 1, and then the same thing for row 2, row 3, and row 4. So we're getting all of our information, 20 full outputs, all with very, very little code. One line of code. Not a lot of work involved. So you can see with the combination of loops and nesting, we can produce some very effective results, which you're going to be able to apply in a lot of situations, especially the world of gaming. So that's it for counted loops. Next up, we go into conditionals.